Welcome back to The Explainer. So glad you're joining us. We're actually going to skip the usual agenda today because I want to jump straight into a really fascinating sustainability data mystery, contextualizing SASB data. Let's figure out how we take raw, chaotic numbers and transform them into clear, actionable intelligence. Okay, let's just dive right in. Imagine you're an analyst, right? You're reading through the annual report of some massive meat and poultry processing company. You flip to the environmental section, and boom, you were hit with this number: 500,000 metric tons of gross global Scope 1 greenhouse gas emissions. I mean, it's a massive, intimidating figure. It sounds incredibly heavy and serious, doesn't it? But here's the multi-million-dollar question you've got to ask yourself. Is this actually a sustainable company? Does that raw figure of 500,000 metric tons tell you anything meaningful at all about their environmental efficiency, their operational excellence, or even their risk profile compared to their peers? Well, the harsh reality is, without context, we have absolutely no idea. That raw number is essentially useless for comparison. Think about it. If this company produces 10 million tons of food a year, 500,000 tons of emissions might represent incredible, industry-leading efficiency. But if they only produce 50,000 tons of food, that exact same emission number is catastrophic. Raw sustainability numbers are just noise until we give them a proper baseline. And this is exactly where the Sustainability Accounting Standards Board, or SASB, steps in. Specifically, we're looking at the SASB standard for the meat, poultry, and dairy industry. This document is essentially the rulebook for tracking all this raw data. It mandates exactly how companies should report their greenhouse gases, water withdrawals, energy management, and ecological impacts. But the architects of this standard knew perfectly well that just listing raw data wasn't going to cut it. Now, tucked away at the very end of the disclosure topics is a tiny but incredibly powerful section: Table 2 Activity Metrics. These activity metrics basically act as an essential decoder ring. They allow investors and analysts to finally make sense of all the environmental and social noise that a company reports. So the crucial point here is how the standard actually defines this tool. If we look at page 4 of the introduction, SASB states that activity metrics, quote, quantify the scale of specific activities or operations by an entity and are intended for use in conjunction with the metrics to normalize data and facilitate comparison, end quote. They are the missing puzzle piece, guys. They tell us the true scale of the company so we can actually judge their footprint fairly. Let's see how this builds into a brilliant mathematical metaphor. Think of sustainability analysis as a fraction. On the top, the numerator, you have your raw sustainability data, stuff like total water withdrawn in thousands of cubic meters, or total energy consumed. But that fraction is totally incomplete without the activity metric sitting at the bottom as the denominator. The denominator is what actually grounds the data into reality. So what exactly are these vital denominators? Well, let's look at metric 1, processing facilities. The first activity metric, coded as FBMP000.A, is simply the number of processing and manufacturing facilities. By counting the actual physical facilities, we quantify the physical operational footprint of the company. It makes sense, right? A company with 50 sprawling processing facilities is inherently going to use way more total water and electricity than a company with just 3. Knowing that facility count allows an investor to calculate the average impact per facility, which gives a much clearer picture of their operational efficiency. So that covers the physical footprint. Now let's shift our focus to metric 2, protein production. This one brilliantly illustrates just how granular the standard gets. Metric FBMP000.B requires the disclosure of animal protein production. But here's the kicker. It's not just one giant aggregated number. It has to be tracked by category, because raising beef obviously has a vastly different environmental footprint than producing shell eggs or milk. Plus, the standard dictates that the units of measure have to be appropriate to the product. We're talking metric tons for pork, head count for livestock, or liters for dairy. Crucially, it also requires companies to disclose the percentage of this production that's outsourced to contract farmers. That gives investors a really clear view of the company's direct versus indirect impact scale. All right, we have the raw data, and we have the activity metrics. Now it's time for contextualizing for investors. Let's walk step by step through a hypothetical investor's workflow. Step 1, they collect the raw topic data from the sustainability report. Let's say they grab the total water withdrawn. Step 2, they go to Table 2 and identify the relevant activity metric, like the total metric tons of protein produced. And then Step 3, well, that's where the magic happens. They divide the raw water data by the total protein produced.
This simple division creates an intensity ratio, specifically the amount of water used per ton of meat produced.
Visually, the transformation is stunning. First, you have the raw data, just chaotic, loud numbers that make it literally impossible to compare a boutique organic dairy farm to a massive multinational pork producer. But then, you have the normalized data. By applying those activity metrics, we've created a totally level playing field. It's the investor's key to cutting through all the noise and finding the true signal of efficiency and sustainability, regardless of the company's sheer size.
So I want to leave you with this final kind of provocative thought. If you only look at the raw numbers, Company A might look like a massive polluter compared to Company B. But what if Company A emits slightly more but feeds 100 times more people? Without the activity metrics, without knowing the number of facilities and the exact volume of protein produced, you would be completely blind to that reality. The denominator literally changes everything. Thanks so much for diving into this explainer with me, and keep looking for the context behind the numbers.